let's go back to middle school for just a moment. When you first learned how to graph a line, for example, your teacher probably gave you this, gave you a table of values and said, oh, like x plus 1. So you're going to get values like that, and you're going to just say, oh, well, -1 plus 1, 0 plus 1, 1 plus 1, 2 plus 1. And then you plotted your points. Oops, that's not it. -1, 0. There we go. There's 1, there's 1, there's 1. And you got your line. You're like, yay, I have a line. And that's how you learn to graph a line. Up until this point of the lesson, we have literally been plotting points or converting points from rectangular to polar or polar to rectangular. Now we're going to plot a whole bunch of points and connect them and see what the equations end up graphing like. Will the calculator do it for you? Yes. Why are we doing it without a calculator at first? Because when you start dealing with integrals and derivatives of these things, you need to know where an equation starts or stops. We already have an understanding of that rectangularly. Like I could hand you this and I'd go, and I'd say, all right, we're gonna go from x equals -1 to +2, boom, and you would know it was that. But then if I give you some crazy curve and I say, we're gonna go from pi/3 to 7pi/4, like wait, where does it start? How far out did it go? There's an understanding we have to gain. Okay, enough talk. Here's the equation, θ/2, and that is r. Our radius is half of our angle. So our radius is 0/2, which is 0. Yay. All right. Our radius is pi/3/2, which is pi/6. Okay? At this point, you're thinking, can't I just double the denominator? Yes. So let's do that. So 2pi/6, that's pi/3. Double that denominator, which would be doubling 1, so pi/2. Double that denominator, which would be 4pi/6, which is 2pi/3. Double that denominator, 5pi/6, and that would just be pi. Okay, they are telling us, whoever they is, that we need an r and a theta as a coordinate. So the r theta as a coordinate is going to be written here, and I'm going to use decimals for the r values so they're a little more practical. So I'm going to use a calculator for just a moment. And we're dealing with a coordinate of 0, 0, clearly here, rectangularly and polarly. That's the thing. Our radius is pi/6. However, for practical purposes, to know how far out to go, I'm going to convert it to a decimal. And so I have 0.524, 0.524, comma, pi/3. All right, pi/3 converts to 0. Whoops, whoops, whoops. No, it doesn't. No, it doesn't. No, it doesn't. You can't see my calculator, and I'm not going to show you. Okay, I will. You talked me into it. 1.047, comma, 2pi/3. All right, pi/2 is 1.57 something. I should know this. Not that we're really going to be able to get that exact with it. That was our theta value. We don't have to get too exact with it because we're just going to be kind of estimating how far out we go. So we're not going to be dealing with the nearest thousandth in between here just by estimating. But you'll see what the general shape is as we move forward with this thing. It's really going to be neat. All right, so 2pi/3, 2pi/3. I could just double the pi/3, and I would have 2.094, comma, that one was pi/3, I believe, and let's see, 5pi/6, oops, no parenthesis needed there, and that is 2.618. The whole purpose of this is so we'll just have a way to estimate our radius, and that was at 5pi/3, and wait, that was 4pi/3. Fix that, okay, if you're copying me, fix that one, it was wrong. And then this one's gonna be at 2pi, so we make a full circle with this thing. Just close my parentheses out too. This is getting tragic. And this is going to be 3.1415, so 3.142 for using 3 decimal places. Okay, I'm going to double check my work. My theta values should be consistent all the way through. They are. My r values are converted. They are. All right, let's do it. Let's do it in blue. 0, 0 is my first point. I start here. And then I go half-ish to half to pi over 3. So 1/2 and then pi over 3. Okay? A little more than 1 and then 2 pi over 3. A little more than 1 and then 2 pi over 3. Okay? 1.5-ish to pi. So 1.5 all the way around to pi. All right, a little more than 2 to 4 pi over 3. A little more than 2.5 goes to 5 pi over 3. Let's just do it this way. And pi, 1, 2, 3, and a little more, goes to a full circle. Let's connect them. Ah, isn't that neat? I think it is too. All right, let's graph just a little bit. Let's do some graphing. I am currently, based on a previous video I had done, in parametric mode. So it's a good practice for us to be able to switch between modes and realize we're looking at the wrong thing. So we're gonna press mode, and we're gonna go to polar, which I think is the first time we've done that. Let's go polar. All right, when I press y equals for polar, I'm not gonna get y, I'm gonna get r. Oh, okay. And you press the same button you've been pressing for x or t. Now notice it's theta. There it is, theta over 2. And let's just go on a standard window. Let's zoom standard. There it went. That was it. That's exactly what you just drew. Ours is prettier, of course. If you want to, and this is really neat, you could press window and adjust your theta max. So our maximum theta was 2 pi, which is what we had on the calculator. We could adjust it to be 4 pi, and instead of it going around one time, it's going to go around twice. But considering the equation is pi over 2, it's going to continue outward. It's not going to loop back into the inside. All right, so graph. There it goes. There it goes again. Yes. Isn't that neat? How many times do you want it to go this time? Let's go 3. 3, no. Whoa, 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 whoa. Good learning opportunity here. If we're going to go 3 loops, we're not going to go 3 pi. We're going to go 6 pi. Whoops. And we graph it. 1, 2, 3. There we go. That's more fun than you've ever had. I'm having so much fun I can't stop. Watch this. Let's also do negative theta over 2. What? Isn't that neat? I think so too. All right. Feel free to have as much fun with that as you're allowed to have.